You're welcome. Um, this is about the lab one. We will be using the JupyterLab app on the ACES Open On Demand portal for the users who has never used the JupyterLab before. This is the interface for the JupyterLab. You can see it included several sections. Here, it's kind of like a file browser. You can have different files here, like Jupyter Notebook or Python files. And also, there might be some directories, and you can go to the next level directory. And also, this is the main working area. If you double click on a file, this will open a tab here, and you will be able to edit the file. And also, you can open a terminal, you can open a console, you can do a lot of things here. So that's why I prefer JupyterLab than Jupyter Notebook, because we include multiple files, and we can easily switch between the files in a JupyterLab. And here are some very useful and helpful resources for your future learning or for your self-learning. The first one is our Texas A&M High Performance Research Computing webpage. There's a link here. So if you click on it, and you will be able to check the status of our clusters. For example, today we are going to use the ACES cluster. You can check how many nodes are being used, how many cores, how many jobs, and there are how many jobs are running, how many jobs are in the queue. So this is very good, and sometimes I use this our web page to check the status of the cluster, and also sometimes we post the maintenance notice here as well. So you're welcome to. And also for today, as I mentioned, we will be using the ACES cluster. And so it's not bad to check the quick start guide for the ACES cluster, right? If I click on this, and you can see we have several clusters, quick start guides here. The first one is the ACES quick start guide. You can check the usage policies and user guide, how getting account, portal logging, and some more information as well. If you want to get some detailed information for ACES, you can click on user guide, and then the ACES is the first one. So you can check the hardware. So we have different, for example, you can check the compute nodes, how many, and you can also check what accelerators we have. For example, here we have H100 GPUs, A30s, and their quantities as well. For example, we have 30 NVIDIA H100 GPUs, and also we have a 120 Intel data center GPU. So you can choose the accelerators that you want to use for your workflow. Some other information as well. And even for here, we have examples to run on the accelerators as well. For example, here I put some examples here for running some AI machine learning on the Graph Core IPUs, Intelligence Processing Unit, and also Intel PVC GPUs. So you can use this user guide as a starting point to get on ACES. And next one, today we will be using the ACES Open On Demand portal to access the cluster. I guess everyone has access ID already, because we yesterday we have added you to our ACES cluster, and so you guys can work on some hands-on exercises today. If you don't, you can go to the access support and to apply, for example, create an account, and also for the allocation. we add you guys to ACES educational allocation. I think it's good for maybe half a month or to 1 month. So after that, if you still want to use ACES accelerators or other components, you can apply for some allocations through ACES. So I think it's from here, allocations, maybe get started. And here, if you click on project types, you can see the access they offer one, two, three, four allocation types from small to big. So maximize is the largest allocation. So you can start with the applying for explore allocation and then get bigger allocation later. So so this will if you want to go beyond the like just for some training, you want to run your workflows in a long term, and then you will need to apply one of these project allocations. So I get the first one is the easiest. So if you want to start with a small allocation, you can apply for the explore allocation. So and also we have HPRC YouTube channel. So if you go to our YouTube channel, you can see we have posted many videos, short courses videos. We have about 116 videos here. If you are interested in, for example, Julia or IPU training, as I said, the intelligence processing units, some other accelerators, for example, Intel data center GPUs as well. We have posted these short courses videos on our YouTube channel. A lot of useful information here. So I strongly encourage you to subscribe our YouTube channel and then get a notification when we upload the new videos. Now we have about 2,000 subscribers already. And the last but not the least is our help desk email. Even after this short course, you can still contact us through this help desk email. If you have any questions about using our computing clusters and how to get on our cluster and how to use some specific components or you get some errors when you run your code on the accelerators, you can always send your questions to our email, and then we will be able to help you from there. Okay, you guys may wondering, hey, what is NSF ACES? ACES stands for Accelerating Computing for Emerging Sciences. So it's a actually we have passed the testing phase. It's kind of like in production now, and we have a lot of different types of accelerators on this computing cluster for numerical simulations and AI ML workloads. And also we provide a lot of like short courses like this, tutorials and workshops at conferences to researchers so they can get our ACES cluster and use the different accelerators on our cluster. And also we collaborate with other high performance computing centers and universities on computational and data enablement research and benchmarking. For example, we published a lot of benchmarking papers on different accelerators at different conferences. So, this is a collaborative work effort with other HPC centers and universities as well. So We also welcome collaborations with you guys, and if you want to run your workload on our ACES computing cluster and test the performance of our, for example, H100 GPUs or Intel data center GPUs, you are welcome to contact us, and we will help you from there, and then we will benchmark the performance for your research workflow, and maybe we can publish the paper on that as well. So these are a table for the ACES accelerators. As I said, we have various types of accelerators on ACES. So the first one is the graph core IPUs. IPU, as I said, stand for Intelligence Processing Unit. We have 32 of them, and 16 of them are classless IPUs. 16 of them are bow IPUs, and they are standalone standalone systems. So they are not in Slurm, and they are not composable. ACES have some composable components, but IPUs are not one of them. So if you want to use IPUs, you will have to log into the systems and then use the IPUs directly. We also have Intel FPGA, Beware FPGA, Nexus Silicon coprocessor, NEC vector engine. This one is the Intel Optane SSDs. We have 18 terabytes. They can be addressable as memory with the MemVerge memory machine. So if you require large memory for your workflow, and maybe you want to use the Intel Optane SSDs, we have research scientists working on this and testing the performance of this composable memory. And if you are interested, you are welcome to contact us as well. For today, we are going to use the NVIDIA H100 and the A30 GPUs. So I reserved 8 of them. I'm already using 1. So I think 7 lucky attendees will be able to use the rest GPUs. The remaining attendees will use the CPUs. For Intel Data Center Max, this is Intel PVC GPU, and we call it, but the official name is Intel Data Center GPU Max 1100. They also have 1550, I think, but we have 1100. We have 120 of them, so we have a large quantity of them. If you want to train your model on a lot of nodes and distribute it, and you can use our Intel PVC GPUs. And also, next, I would like to introduce about composability at ACES cluster. So when we talk about composability, we are comparing it to traditional layout. For example, for a traditional node, it can have only a dedicated number of accelerators or memory to that node. For example, we can have 2 A100 GPUs on node. We can have 4 T4 GPUs on node, but they are dedicated and they are static. They cannot be moved around. So that's very not so flexible. And also, this is not very good for the resources usage for a data center, right? If someone, for example, take a node and use only 1 of the GPU, but the 3 of the GPUs are idle, and that's a waste of the data center resources. So for composable layout, the resources will be in pools, and for example, server pool, accelerator pool, and a memory pool. So when we want to compose some node, we can use here ACES use the liquid fabric. It can fetch some, for example, 16 or for example, Intel data center GPUs to a node, and then compose this node. And also it's easy to dynamically allocate the accelerators to different nodes. So this can optimize the usage of data center resources. So I think this is the advantage of composable layout to traditional layout. Any questions here?
Yeah, I just was wondering, in generally, like when we learn, run any sort of machine learning algorithm or deep learning algorithm via HPC. Uh, is it like we have to build the algorithm in such a way so that it can basically utilize all the cores available? That means like we have to basically
That's
send
a great
every
question.
individual batch to different cores, or the algorithm itself like goes into the node and then divides every batch into different cores and process it parallelly.
You I think you are talking about user level composable, right? So
Right.
whether you can compose a node based on your needs. For example, hey, I want to use a lot of H100 GPUs on a single node. Now,
Mm-hmm.
can I do that? And
Mm-hmm.
actually, we that is our ultimate goal to let a user compose their nodes. But there are still some technology difficulties for to achieve this goal. At this time point, it's our system admins. They will do some tricks to compose the node for the users. Um, so it's not user level composable yet. So uh, but we can still move the accelerators around and to different nodes, and then I once tested like how many H100, 16 H100 uh,
Mm-hmm.
GPUs on node, and also 20, I think maybe 30 A100 GPUs on node. Um,
Okay.
and
So in that
also, mhm.
no, so in that case, I think we have to basically send individual batches to individual nodes in order to process it parallelly, right? When we are
Um,
doing
for now, it's the system administrators to compose the node. So you will be using the Slurm script. If you use
right,
Slurm,
right, right, yeah.
the same as on the traditional node.
Okay,
And
okay.
so um, you can check out, hey, how many GPUs have already been composed to that node. Hey, I can use that
Mm-hmm.
node. We try our best to compose as you need it, but sometimes it's not so um, practical, and sometimes um, we will be and also I want to mention that sometimes the composability have some capacity. For example, when you go beyond 8 H100 GPUs, for example, on a node, your workflow may experience a decrease in performance. It's not so fast actually. So that's also one result from our benchmark. That's why we do a lot of benchmark studies. And so um, uh, yeah, any more questions?
No, thank you.
Okay, you're welcome. Okay, next we will be get on our ACES Open on Demand portal and um, access the ACES cluster. So this is our ACES portal, the page. Oh, I forgot to mention that. We have, for example, I want to go to Tamil HPRC. And if you click on the first link from the Google search result, you will get our web page. Under the portal menu, we have ACES portal access. So if you click on this, okay, I'm sorry. Maybe I have saved the password and the username, so it let me um, it let me get on the Open on Demand portal directly. But if for you, you will need to you will need you will need to go through the access authentication. For example, you will have to choose an identity provider. This can be your university or Access CI, Exceed. If you choose the Access CI, you will need to provide your Access username and password and then log in. And you will be on the ACES Open On Demand portal like this one. So I will give like, excuse me, give 1 minute for you guys to get on this page. So if you have any questions, you can let us know. I will launch a poll. I have I'll launch a poll to see if everyone see. Sorry, I don't know why I cannot launch the poll, but I was in the process of creating a poll question. Can you give me a thumbs up if you are on ACES On Demand portal? So, and if you have questions, you can give me a thumbs down. We can help you. We have some Tamil HPRC staff members on the Zoom as well. Okay, I say thumbs up. Okay, great. And then next we will be go to the clusters access shell access. So this will be we will be using this. But before this, I would like to introduce some features of the ACES On Demand portal. And these are the directories, home directory and Scratch directory for you. This is your personal home and personal Scratch. And for example, if I click on Scratch, I can see all the directories and the files in my Scratch directory. So this is very convenient. And also, if you want to edit some file from here, you can click on the drop-down button here. You can click on Edit. So you can edit these files. So this is very convenient for some, if you are not comfortable with some other editors like Vim or something, you can try our file editor from here. The next is the jobs, and we will be, you can check the status of your jobs here as well. For example, whether it's pending or running, like that. And also here we are kind of like in the process of building a Jonah composer. This is good for the researchers who are not familiar with the HPC and resource management system like Slurm. In the Jonah composer, we will be helping you to compose a Slurm job script. For example, if I want to do a PVC, Intel PVC job, I would just type Intel PVC, and you can see this will directly create a directory in your Scratch. For example, I want to use the Intel TensorFlow container. And this will ask you to, hey, do you need to upload some files from yourself? You can, yes, or I need to upload some directory, actually. That's okay. And also, if you want to add some more modules, you can do it here. The default number of cores or nodes is 1. And hey, I want to use the Intel PVC, for example, Intel PVC GPUs. The total memory, for example, you can choose some number, for example, 5 hours, 1 account. These are optional. So by doing this, actually, you can find, hey, I have a Slurm JavaScript composed, and I can just click submit and then do the job. This is actually for a simple example for CIFAR 10 classification for TensorFlow framework. Actually, you can submit and it will be running. So you can see you can get a job ID, and then after some minutes, you can find the output file in the directory. But it's still in the process. So we are adding more models, data set, containers, shared environments to this one. And also we are building a more user-friendly interface as well. So I just gave an example that it works. Next, let's click on the clusters. I guess everyone is on the cluster now. I'm on logging node 2, actually. Can everyone tell me which logging node are you at now? For example, you can just copy and paste. We actually have 3 logging nodes, logging 2, logging 3, any one on logging node 1. Yeah, in the prompt, you can find the log. Oh, and we have Zhiyang on logging node 1. Hope you are not alone there. Next, we will be needing to copy the training materials to your personal Scratch directory. So here are the commands for copying the materials. I would like to show you guys where to find the course slide. Here on our webpage, under training, we have courses. If you go to the short course list for fall 2024, you can see AI TechLab in Jupyter Notebooks. If you click on View Details, for here, you will find a link, a PDF link to the slides. So I will copy and paste this to the chat. You guys can download the PDF, and then you don't have to type all the commands. You can just copy and paste. So sometimes you can make typos, and that can waste some time. So okay, I guess I will give another 1 or 2 minutes for you guys to copying the training materials to your personal Scratch directory. And so next, we will be using another feature on our Open On Demand portal called Interactive Apps. This is a long list of apps that we have included on the here, and specifically we have created an app for today's short course, the JupyterLab app, and this is a regular one. This is JupyterLab AI TechLab. It has a reservation injected, so you guys will be landing on some reserved nodes, the GPU nodes, and one CPU nodes, and so that will be easier. You don't have to compete with other users on the cluster for resources, right? So We don't want to make it hard to get a processor. Next, on the JupyterLab page, so 7 lucky attendees. You can, for example, I don't know, you can choose the first available GPU, and if you choose it and choose number of GPUs 1, and number of hour 3, number of core 3, total memory 5. If you don't care if you want to use about the GPU or CPU, you can just choose CPU only. But we only have 7 GPUs, so the first 7 attendees who choose node type first available GPU and all these parameters, and click on launch, you will be landing on a GPU node. If you choose it and you wait for a long time, it might indicate that all the GPUs has been taken. So you can go back and go back to the JupyterLab interface again and then choose CPU only. So, and also for here, we will be needing to activate an environment for today's short course. It's a shared environment created by Tamil HPRC. So it's called AI Labs. You will need to copy and paste the path into this box and fill other parameters. And let me know if you land on a node other than AC014. That means you get a GPU node, because AC014 is a CPU node. So let's do this together. I already get one because I don't want to compete. So interactive apps, JupyterLabs. The Anaconda module is Anaconda 3 2022.5. And this is the one that we use to create the environment. So choose this module version and also copy and paste the environment into the box, AI Labs. If you want to use the GPU, you can try to use, hey, congratulations, Esteban. You get a GPU node. AC0 65, I think it's a GPU node. And the number of GPUs 1, number of hours 5, number of cores 3, total gigabyte memory we can choose 5, and then after that these 2 are optional. So if you want to, I think you don't have to fill in these the account information or email information. If you want, you can test later and then click on launch. Okay, great. AC065 is a GPU node. stat-p-gpu- let me check actually. Okay, we have let me see. I reserved 55, 64, 65. So we have we have some users on the GPU nodes now, and also AC014. Okay, this is the CPU node. So I guess some users may get our CPU node. Oh, someone okay, I think most of us are on the GPU node now. If you wait too long, for example, on the page, for example, if I click on this, if you wait on this page for too long, like more than 1 minute or 2, you might want to delete it and then go back to the JupyterLab AI TechLab again, and then choose CPU only. For example, if I launch another job on CPU, I'll do CPU only. I would do, I think 3 hours should be good enough. Um, 3 cores, five, okay, like this. After you get this, you connect it to JupyterLab. Um, for example, actually, I want to show another, I guess it has been closed. Let me get back to my, no, this one. I think the active jobs, no data available. Okay, it shows my Jupyter AI TechLab is running, and my interactive sessions. You can see if you click on this thing, kind of like a window or something to session icon something, you can go back even if you click close this web page, it can open it again for you. So for the session ID here, if you click it and you will look at some files generated for you. For example, here the output log, you can check what modules has been loaded, what environment has been activated. For example, here, you will see, hey, we have loaded the web proxy module and Anaconda module. We specify this one. This one was loaded uh, automatically because we want to use the uh, uh, we want to get internet connection on the compute node to download some data set. So, and also the environment has been loaded as well. You can check the packages here. For example, here we use the PyTorch. Here, for example, PyTorch CUDA that has been loaded as well. So you can always check if, for example, when you encounter some errors of modules not found, but you are sure that you have installed that module in your environment, you can check if the environment has been activated properly. So next, next we'll be doing some exercises, hands-on exercises. So let's go back to the Jupyter notebook. Am I still on there? Okay, I will click on connect. So if you have copy the AI TechLab into your Scratch directory, you should be able to find it in the file browser in the JupyterLab. So we can click on it, and there are some files here. I run some files, so it generates some other files in the, so it may look a little different. So let's open the first JupyterLab notebook. We can skip the first part because we have talked about that in the lecture. And now we will need to test if the module has been loaded correctly. For example, here, I have typed this. I think yours has no answers. It's like this, it's blank. So you will need to test the NumPy, test pandas, to see if they are imported properly. So for example, hey, I run this code cell, I import NumPy as NP, and then I run this code cell. And it give me a number here. It means this code has been successfully run, and also the NumPy has been loaded into this Jupyter session. Next will be test pandas. For example, let's import pandas as PD for short. And I usually use Shift Enter to run the code cell. And of course you can do, like, for example, I want to select this code cell first and then click on the run button on top. That's also okay. Um, for example, let's do the uh, matplotlib. Import matplotlib. Most of the time we will use the pyplot submodule as PLT for short. And this is a very common alias if you use this. And also I want to point out, oh, okay, I think that's good enough. And then next, we will need to test the scikit-learn. Are you guys following along to type the code into the code cell? If you are, please, yeah, give me a thumbs up. Great. And is it working so far? If it's like you encountered any errors, hey, I get a no module not found an error, or you can give me a thumbs down, and then we can check that as well. So for checking scikit-learn, scikit-learn module name is called sklearn. So you can use tab actually, it will auto-complete. For example, I will do linear model from this to import, for example, linear regression or something. If you tap the tab key, it will give you like some options. Hey, I want to import linear regression. Okay, scikit-learn has no problem either. So the last one is the PyTorch for the deep learning framework. And I will do import torch. So run this one. Okay, no problem either. So that's great. And if you have any questions, we can you can send me a message or so we have completed the first section. That's great. Congratulations. And then I
One
think it's
question.
yes.
What was the tab thing that you were talking about?
Oh, okay. For example, here in our we'll do this again. For example,
Oh
here
no, I mean,
if you okay, if you forget some module name or something, you can always use like tab to autocomplete for you. For example, scikit-learn, I forgot to how to spell it, or for example, the some module, it will give you some hint for here. For example, linear model. I want to do linear model, and then you can. I'm tapping the tab key. So from this linear model, for example, I want to import linear regression. So I don't have to type all of them. Even you can see there are some upper cases or lower cases that might matters. So the autocomplete is very convenient for here. Hope that helps you. Find my Jupyter notebook. And this is, we have completed the first one. The second one will be pandas. Let me go back to my slide. Oh, because today you used the shared environment, of course you can create your own environment on ACES. And you can, for example, this is an example, and you can create the environment, and also you can activate your own environment. For example, you can give, I call it AI labs, but you can call it something different. You can, of course, uh, this is for your own project. You may not use like PyTorch. You may use like TensorFlow. You can install TensorFlow in your environment and then activate it from the environment from here as well. So this is another option. But for today, I know sometimes the environment is tricky and it takes some time to complete. So we will be using the shared environment. That's good enough for today. So next is about the data exploration. As I said, we will be learning two Python libraries. One is called Pandas, the other is called Matplotlib. There are two data structures in Pandas. The first one is called series, and it's a 1D labeled array. So it has two an array of the value, the data, and then associated array of labels. The data frame is a primary pandas data structure, is 2D and labeled as well. You can add columns, or you can make it bigger or smaller. It's add columns or drop columns or rows. That's doable, and it's a size mutable. And also in data frame, for each columns, the data type can be different. So it's called heterogeneous typed columns. This is an example about series. For example, this is the associated index. For example, it can be A, B, C, D, or the value is 0, 1, 2, 4. For the series, it can hold any data type of integer, strings, floating numbers. Here I give an example of time series stock price data. For example, we have the stock price data for Google and for the past few years. And for example, we can use the index, use the time date data if you as the index, and then the price as the value. So we can retrieve the stock price on a certain day. So this is one example of the application of series in pandas. The data frame, you can think of it as a spreadsheet. It's a 2D data, and then it has columns, and also it can include different data types in the data frame. For example, integer, floating, and also string and Boolean variables as well. So today we're gonna learn how to create a data frame, how to retrieve rows and columns from the data frame, dropping entries, selecting, filtering data, sorting data, and input and output means like you read the data from a file to a data frame, and you write the data back to a file and save it for future use on your disk. So next, we will be opening our Pandas Jupyter notebook. And actually, the JupyterLab on the left sidebar, you can see now we are in the file, kind of like file browser view, but if you click on the this triple dot dash icon here, you can actually get an outline for this Jupyter notebook. This is very convenient when you switch between sections. So the first one is the series, and we know that it's 1D labeled. First thing first, we will need to import pandas, or for this one, we use series, so you can directly import series actually. So if I use the shifter enter, it will run this code cell and then move to the next cell. For example, now you can see the next cell. Actually, this is a test cell has been selected. So how can we create a series? We can use a Python list. Here, for example, hey, I want to convert this Python list to a series. We can just use this series and pass the list to it, and then this will create a Pandas series. You can see actually it has two columns. The first one is the index, the second is the value. By default, it's integer index starting from 0, 0, 1, 2, 3, 4, 5, 6. So we have 7 numbers. Next, we can retrieve the value and the indices from the series as well. We can just use the values attribute and the index attribute. And this is very easy. So you can retrieve all of the values here and retrieve the index. But now it's just a range index. It tells you the start and stop and the step. It doesn't just give you like a 0, 1, 2, 3, 4, 5, 6. You can see that actually the stop is not inclusive, so we stop at 6. For example, some people may think, hey, the integer index is not so useful. I would like to customize the index. Yes, you can customize the index of a series. For example, we have some data here, and I want to call these, I want to make the index different, not just a 0, 1, 2, 3, 4. I want to do it A, B, C, D, E, or sometimes, for example, I want to, for example, these are values or of, for example, the number of some numbers, for example, if we don't have the negative numbers, for example, the number of animals, cats, dogs, cows, something like sheep or something like that. And you can customize the index from here as well. So here I just use A, B, C, D, E. So now you can see the index column, it's A, B, C, D, E now. It's not 0, 1, 2, 3, 4. So can we still use integer if we have customized the index into like string or labels? Yes, we can still like use the integer. For example, this will be our fifth, right? Because the integer index from 0. And so let's run this. So I get -5. So although the index has been a labels now, but we can still use integer to retrieve the value. Similarly, we can, of course, we can use its label. Do they equal? Yes, they equal. So, and also, besides retrieving a single value, we can retrieve multiple values at one time, and you can pass a list of labels into the series, and we can retrieve these. So, example A, C, B, and also the order of these labels also matter. For example, if I put a C here, I put a A here, you can see actually these orders has been changed. And also we can do some filtering, like get some values, for example, greater than 0. We can use this sir underscore greater than 0, and then what it will print. It will print these values are greater than 0, because in the series, if you remember, the last two values are negative numbers, -3 and -5. So they have been filtered out. So actually, what is this? I want to print this. Actually, you can see it's an array of Boolean variables, true, 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 false, false. It tells you like for this label, it satisfies the condition. So it's a true for this one, it's a true. But for this one, it's false. When we apply this onto the series, it will kind of doing some masking. So it will masking the false positions and only give you the the values that are true. So okay, and here there's an exercise here. I was trying to let you create a series with the month and the number of days. But I guess due to the time limit, and we will not type all these stuff, and I have to do the solution for you actually. So we have some hidden cell here. If you click just a single click, and you can see this will expand the answer. You can just copy and paste. So now you can see we create a panda series with the names of the month and the number of the days. And here also we can do some filtering. For example, here I want to find the month that has number of days less than 31. Okay. So it tells you February, April, June, September, November in 2023 has less than 31 days. So this is just a very simple example, and you can type this after the class, I think. Next is the primary data structure in Pandas. Most of the time, we will be using the data frame for machine learning. For example, you read some data into a data frame, and then you retrieve the data that you want to use to train your model or test evaluating model. So data frame is very important, and then so we imported the data frame and also NumPy. We will use NumPy as well. So run this code cell. Here, we will be using a Python data structure called a dictionary. It's a simple data structure. You can see we have curly brackets, and also inside the curly brackets, we have key value pairs separated by the columns. This is the key, this is the value. For example, here, this is a old car. And also, this is just an example of a Python dictionary. Next, we will be using some another dictionary. For example, the population of some states in some years, and Virginia, Maryland, maybe, and a population, for example, 5 million, something like that. And we put it in the dictionary. And then we can just use data frame to convert this dictionary into a data frame. And then that's run this code cell. Now you can see, hey, it has a nice layout, and it has the state column, year column, and population column. So, and also we can use the type keyword to check the type of a variable. For example, here, it tells you, hey, this df_1 is a pandas data frame. This is also another hands-on exercises, but because there are a lot of, if you want to type it, there's a lot of typing. So for here, again, I prepare the solution for you. So you can see actually the data is a Python dictionary with the key value pairs. The key is the column name, and the values are a list of Python list. You can see, for example, the country is the United States, China, Japan, and Germany. And for continent, the values are America, Asia, and Europe. So the GDP billion dollars, a list of numbers, and the population in millions. So you can just copy and paste it, because we will be using this data frame in the future, in the next few exercises. So you can just copy and paste it. Now you can see the data frame now. And also we can do some operations on the data frame as well. For example, we can specify the sequence of columns, and we can even make a column to be the first index column. But now we have the freedom to specify the sequence of columns. For example, what we have the data one, for example, this is the dictionary, right? So we can specify, hey, I want your columns in the order of year, state, and the population. Okay, let's try. Let's see if it's like this way. Yeah. Now, hey, I can see the year are in the first column, and then state, and then population. Next, also you can put, for example, just an example exercise. For example, I want to put the population in the first column. Yeah, you can move it to the first column by specifying the order in the columns argument. We can also add a column to the data frame. So data frame is a size mutable, so we can always change the size of the data frame. Still I'm using the data one. And now you can see besides the three columns, I'm adding another column called unemployment rate. Unemployment, this is short for unemployment rate, for example, here. But you can see this column, because we didn't pass any data to this column, so we can see a lot of NaNs here, right? Not a number, not a number. How can we do this? If they have a number, same numbers, we can just use data frame fill in a method. We can fill some number, for example, 5.8. Maybe they're in these states have the same employment rate across these many years, 5.8%. We can do this. If they're not the same, for example, we can also call the column and pass a list of data to this column. For example, I have I have some data for these two states, and they are 5.8, 4.9, and these are not real data, so don't cite these data anywhere else. So you can see actually these columns has been filled with these data as well. So this is we can add a column and fill the data to that column. And also we can retrieve a column. For example, hey, I want to do some linear regression, or I need to use this column. For example, for training the machine learning model. And yes, you can do that on pandas. For example, here, first let's print out the data frame, and then we can retrieve a column, for example, a state column, just using the square bracket. Or you can use the dot notation, dot state. These can be like an attribute or something. So you can see we retrieve we retrieve the state. If I want to retrieve the unemployment rate, okay, we have it here. And also we can retrieve the year, population, employment rate. For example, hey, I want to use the employment rate to work on some model, and then yeah, that's doable. So you can retrieve this model and then, for example, do some linear regression across years or something like that. Okay, and also besides retrieving a column, we can also retrieving a row, but it's not just like a square bracket or dot notation. Now we will be using two methods called loc and iloc. Loc is label based, so you can specify rows and columns based on their labels. Iloc is integer position based, so you can specify them by giving some position values. So for example, here, still we want to print out this data frame. For example, here, this is a iloc, right? Iloc, it's integer based. So I would like to give it a number, 3. I get because it's 0 based. So 3 will be the 4th row, like this one. We will be retrieving the population employment rate. The state is Maryland, and the year 2014. So yes, we get these the data here, but now it's kind of like this. So you can see it's a year, state, population, employment rate. Next, you can also retrieve the first row, use number 0. And also, actually, we can change the row labels to some row indices, index to be labels. For example, R1, meaning row 1, row 2, row 3, row 4, row 5. We can specify this. And let's see. The data frame 3 has been changed like this way. Can we still use the integer label to retrieve the row? This is a question, so let's try this one. So still, you can although the label is the index is labeled now, but we can still use integer to retrieve the row. For example, I know this is the first row. I want to use iLoc 0. That's still doable. But if you want to use its label, for example, R1, that's also okay. R2, the label is more convenient, maybe sometimes. So now we are on exercise 3. Because we already have the nation economics data frame, if you're not sure, you can copy and paste the name of this variable, and then you can put it in the code cell, and around the code cell, you can see this data frame. And then I want you to retrieve the column of GDP, billion dollars, this one, and save it in your variable called lowercase GDP, and retrieve the column of population in millions, and save it in a variable POPN, and retrieve the row of country Germany and save it in a variable lowercase Germany. Still, you can use the tab K to autocomplete. For example, I want to retrieve the column GDP. Do not forget it's a string. Yeah. Okay, now we can retrieve the GDP column and also use tab K and square bracket. It's a column, so I use square bracket. It's a long name, so I guess print. So it's already there. Okay, now it's not yet. So now we will be retrieving a population column. So I just copy and paste back to the. So population in millions. So we can see, hey, this is the column of population. Yes. And I retrieve the row of Germany. Okay. National economics. Don't forget, we will be using the log and iLoc to retrieve a row. I can see, hey, the Germany, the fourth column, so I've used integer index 3. Okay, now we have country, continent, GDP population of Germany. So I want to see the, okay. I'm even using the alloc, it's labeled based. Let me try if I use a label-based alloc method. Does it work? Oh, sometimes it also works. Maybe the alloc work for both label and integer, but integer may only work for integers. It doesn't accept a label. That's my understanding. Okay, if you have any questions, let me know, and maybe shall move on time. And also we can, for example, we can reduce the size of the data frame. We can drop the entries as well. For example, hey, I have this data frame. I want to drop the column, the rows of the first rows. Now we will pass a list of the row labels, and then we can tell the drop method access index means like I want to drop rows, not the columns. So if we run this code cell, hey, these two rows have disappeared. Also, you can use the integer 0 to be the rows. For example, here, I want to drop the R1 and R4 now. So R1 and R4 disappeared. So, and also you can drop columns. You can pass the column labels and you can specify the access to be columns. Let's see. Okay, now we only have the year and the state. We dropped the unemployment rate and the population columns. So you can see the data frame can be size mutable, and you can add entries or dropping entries from the data frame, and also you are free to retrieve the columns or rows from a data frame. And also we can do slicing or selecting from the data frame. For example, I need a multiple row columns, and we can do for example, in the data frame square bracket, we can do start, stop, and or even we can give it a step size to retrieve the part of a section of the data frame. So for example, here still this is our data frame, and I want to select the states with the unemployment rate less than 5%. We know, hey, these two have numbers less than 5. So here, kind of like we are doing a mask, right? So give an array of Boolean variables, and these two positions are true. If we apply this mask to this data frame, we can get the two rows that satisfy the condition. So, hey, these two has employment rate less than 5. And also we can choose the rows, for example, 0 to 2 and 1, a step size is 1. So it tells, hey, 0, 1. It means like this is integer, so 2 is not inclusive. However, if we do not specify anything in the stop, if we do this 2, step size 2, what does it do? So now you can see it to retrieve every other row from the first row, third row, fifth row. So you can do like this, the odd number rows. And also we can do this, use the labels. Here is just another example about the population, the filtering on population column. So you can see we can retrieve the columns that has a population greater than 5 million. So we can also do sorting on data frame as well. So we can sort either by index or values. For example, here I create another data frame. It has row 312, and the column labels C, A, B, D. I just make it not in order because we want to sort. So practice sorting. So sorted by index. This means row, right? So rows and ascending in ascending order. So now you can see the rows, not a 3, 1, 2 now. It becomes 1, 2, 3. So in ascending order. And also we can sort by values. For example, here I want to sort column D. Column D has ascending order, but I can specify the argument ascending to be false. So it should be, if it's a descending order, so it should be 11, 4, 3, right? So yes, so we can sort a data frame by either index or values. Here, there is another hands-on exercises. I think the time is not so much. So let's just copy and paste the solution there. For example, we can get the even rows of the nation economic data frame. We can also retrieve the rows that has population less than 300 million. Or we can do ascending, we can retrieve the column by ascending order for the column of GDP. Okay, let's just copy and paste. So now you can see, hey, we have retrieved the even rows 0 and 2, and we have retrieved the part that has the population less than 300 million, right? So these two. And also we are doing the GDP in ascending order. So you can see Germany, Japan, China, United States, ascending order. Okay. And the next thing is about input and output. So if you go back to the file browser, you will see a file that is called a King County house data. If you open this file, you can see the data of the houses on a house market, and it has about like 21,000 rows. If we create a Python dictionary for this big file, although it's not that very big, but that's a very time consuming. So pandas actually have some method called read CSV, read Excel, read HTML, read even stata. I think some um, statistical software file, and then they can read all these the data in these files to a data frame. For example, here we have this data file, and we can read it to a data frame called df_5. And also we can use the head method to check the first 10 rows. So you can see the first 10 rows. And also we can use the tail to check the last 10 rows. And also we can use a useful method called describe. It will give you some statistical view of the data. For example, hey, how many counts you have in this column? What's the mean value for this column? What's the standard deviation? What's the minimum value? What is the 25 percentile value or 50 percentile value, and all these? So we can get a good sense of the data. And also we for example here, hey, we find a interesting thing here. This bedroom, some house has 33 bedrooms. Maybe how we want to check we want to retrieve this row to study how this house look like. So we use filtering, right? df_, the column is called bedrooms. We said, hey, a bedroom's number equals 33. Give me that row. Okay, you can see the ID number, the date, price, and the bedroom 33. Actually, you can see it's only have 1.75 bathrooms, and the living area is only like 1,600 square foot. So there must be a typo here. Maybe it only has 3 bedrooms, but it's interesting to explore the data, right? So from something you find it interesting or abnormal or something like that. And also, next, sometimes when you have a data frame, but you want to save it to a file for future use. So you don't want to lose it when you close this Jupyter notebook. So, for example, we have this data frame. We can use to_CSV and give it a name. We don't need an index or header. You can specify the index and header as well. And after we run this, we will have a copy of the data. So you can save it on your computer, and then you can load it back when you need it for the future. So this is for pandas. And next, we will be doing some data plotting. So I will go to the Matplotlib. So Matplotlib, most of the time, for myself, of course, it has other modules, some modules, and most of the time I use PyPlot, some module, and call it, give it an alias name, PLT. So, and also NumPy. If you go to the table of contents here, you can see what is included here. And we will need to generate some sample data. We use NumPy length space. We generate 10 data points, right? So if you are familiar with NumPy, and for y, we just x squared. So you can see the values by printing them, and also we can plot them. So this is a very simple scatter plot. We can specify the markers and the size of the markers and even the color of the markers. There are a lot of useful. I think if we use Shift Tab, if you use, for example, I want to explore scatter function, scatter method, and I can put my cursor on this scatter and then press Shift Tab. It will tell you some parameters. So very useful feature, and also some examples as well. Okay, we will now do the exercises. Scatter plot, line plot. So this is a dotted line plot. You can do solid line or dash dot or some other as well. So I guess how many of you used the Matplotlib before? Raise your hand. Give me a thumbs up if you used this before. Yes, I see. Yeah, I guess this is very basic. So, and also sometimes you don't have to memorize a lot of things. And for example, the marker symbols or something like that. When I want to use some, for example, not so common marker labels, symbols, I would just Google search, and online I can find it a lot. So, and also next will be subplot. We can do subplot in different directions. For example, actually we can draw, for example, subplot we can do here. When we use plot.subplot, we give it a number of rows, number of columns. So we have 2 rows. So this is a horizontally, vertically stacked subplots, right? So we have 2 rows, 1 column, and this is, and also of course we can do horizontal stack. But I want to point out that if you give it the number of rows and number of columns, and this will give you, for example, the axis in the figure. This axis is the actual axis of the subplot. This figure can be the figure canvas, for example, and we can specify the title for this figure. But when you refer to the subplots, it's actually a 1D NumPy array. For example, here we will be using axis square bracket 0. This means the first subplot. If you use axis 1, this means the second plot. Yep. If you do like multiple subplots in 2 directions, that's also doable. 2 rows, 2 columns. And now you can see when you refer the first plot, you will be using 0, 0. And the second one, 0, 1, I mean to the right. And the second row, so you can do multiple subplots. And also we can do color maps. So here we want to generate some data. Here we use some flux cubic potential function. You can see we have some coefficient alpha or phi, and then we will need phi m, phi p, and then we get this flux cubic potential. Let's run this. It doesn't do anything now. And then we use NumPy length space to generate phi m and phi p, and then we use the NumPy mesh grade to generate a 2D grade to combine these phi m and phi p to a 2D grade. And then after that, we will pass the x and y to the function of flux cubic potential to calculate the values on each point. And also we do a transpose here. So now we have X, Y, and Z. So we want to do some plotting, 2D plots, for example, here. We can use, of course, here we use a subplot method, but just to create a one figure. That's also okay, as long as we do not specify the number of rows, number of columns. A very similar method called ImShow, image show. So you can see the plot very similar, but you will have to specify the interpolation. This is called bilinear. Contour map. So this is a different way of representing your data. So contour lines, on each contour line, the values are the same. So this is like kind of like a geological contour lines, like for example, some higher elevation, lower elevation, like that. So this is, I personally like this better than this one because it's giving me some lines. But yeah, based on your personal preference, you can represent your data in different ways. We just gave you some hints, and then you can think, hey, which one you want to use to plot your data. Of course, the same data, you can plot it in surface plots. This method uses the plot surface and pass X, Y, and Z, and you can specify the row stride and column stride and line width. So generate a beautiful plot for data. And also, this is a one frame plot. This gives me a sense of like flow lines, maybe for flow to flow research. They might like this one, the wireframe, maybe to indicate the flow direction. And also contour plots with the projections. You can see, hey, I can plot the surface plot here, and also we can project this onto different views, like the bottom view, the two sides views. This is also very useful for some of the research. Okay, I guess I will move on to the machine learning. Next will be machine learning and deep learning. So in this part, we will be using a machine learning library called scikit-learn. So you can see, as always, we will need to import the modules that we need at the beginning. So here, I imported the matplotlib, pyplot, numpy, and the scikit-learn linear model, linear regression. If you need some other models, for example, logistic regression or others, SVC classifier, support worked machine or something, you will need to import them here. And then for now, we will just run this code cell to get these modules loaded. So after we get these, we know that the modules are loaded successfully. And so first, next we will be needed to generate some data points for training the model and evaluating the model. So now here we just use some random, we generated some data points, use length space from negative 1.5 to 2.0 and 20 data points. And also you can see for Y, we add some randomness to the Y. So it's not just a 3x plus 2, but we also added some randomness to the Y. And then now we can plot to see how X and Y look like. You can see the randomness. Okay, but it's pretty, we can imagine the straight line in our head, like the best fit line. But now we want our linear regression model to learn from this data and get the coefficient and the intercept of the model. So why? So it's you can check the shape of the data, and now we create a model instance based on the linear regression model, and then we pass the x and y to the model, and use the fit method, so it can learn from this data. So it can learn from the data and it get knowledge, right? What are the knowledge? The knowledge is the coefficient and the intercept of the line, the best fit line. So now we can see, hey, the coefficient y, for example, the straight line is y equals ax plus b. The coefficient is a is 3.074. The intercept is 2.06, blah, blah. And so now we know the model has learned something and the knowledge. We can use the score method to get hey, how good this model is. So now we can see, hey, the score is very close to 1. It means, hey, this model is pretty good because this is the determination R square of the prediction. And also we can plot the prediction with the original data set. So we can see the best fit line. It's pretty good. And also this is the line equation. Also, besides just doing linear regression using the model, for example, a linear regression model, we can actually also do the polynomial fitting as well. So we can generate some data points, the same x, but now for y, we included more polynomial terms. For example, you can see x to the power 4, x squared, x, and some randomness as well. If we just use x, that wouldn't be a very good fitting. So we use the horizontal stack, a NumPy horizontal stack. We include more polynomial terms of x, and so this will be x polynomial. And now we will fit x and y, the new x polynomial data and the y data as well. And then we check the coefficient to see how it is good. So now you can see we have these polynomial fitting. That's not bad, right? So, oh, I forgot to run this code cell. So it's still the y data, but you can see it's trying to do polynomial fitting. If I do y has the x to the power of 4 s squared x, and then how does it look like? Okay, it's more curved. And then it's a very good polynomial fitting. Okay, this is about, oh, if you are not familiar with the NumPy horizontal stack, you can use the help to read about it. So I just too many things here. So besides linear regression, like predicting continuous value, we can also, in machine learning, there's another main task is classification, means like you identify an object to a category. For example, you have a bunch of data points of cats and dogs. You have a new data point. You want to categorize this data point, whether it's a cat or dog. So it's a discrete value. So you cannot predict a value between cat and dog, right? It's not like a linear regression. You can predict continuous value like house price. I can predict any number between two values, but for classification, you can only have some discrete values or categories. So this is another machine learning task. And now we will generate some data points. For example, here we use the scikit-learn dataset make blobs method, and we generated two clusters of data points. You can see make blobs, we specify centers to be 2. And also this cluster standard deviation means how dispersed these 2 clusters are. And you can play with this number to see the dispersion of the data point. Next, here we are using the supporter vector classifier to classify these, to draw a separate line between these 2 clusters and to separate them. By using the supporter vector classifier and a linear kernel, it means like it gives us a linear hyperplane, or for here, it's a linear line to separate these 2 clusters. So this also trying to like get the maximum margin of the 2 the supporter vectors. So and also we want to be able to cover the very detailed theory behind it, different machine learning algorithms. If you are interested in learning some more, we have a course. If you go back to Tamil HPRC, also under training, we have micro credentials. For here, we have many recorded courses. For example, fundamentals of AI and machine learning, we covered the basics of machine learning algorithms. And also we have a deep learning with TensorFlow, deep learning with PyTorch, and scikit-learn for AI machine learning. I guess they are still free, and you can register using the register link. But for today's short course, because the time limit, and we will just go over it very quickly, and you know how to run these models on ACES cluster using the JupyterLab app. That's our main goal. So if you want to learn more the machine learning algorithms, you will have to take other courses as well. For example, that is a supporter vector machine classification. We can also use a KN classifier, stands for key nearest neighbors. So it's like you have many data points, and you have a new data point, you have another unknown data point, and you will find the closest n data points. For example, I want to pick 5, and then you find the 5 nearest neighboring data points, and then and also you have the information about the labels of these 5 neighbors, and then they kind of like a vote. For example, we have color labels. 3 of them are green, and 2 of them are red. So the unknown data point will take the green color because it has most votes, right? It has 3 to 2. And also for here, I use the make blobs to create 4 clusters now, and the dispersion standard deviation is 0.6, and also use different colors to color the 4 clusters. And now we created the model, key nearest neighbor classifier model. It has 4, for here, the n is 4. So it will choose 4 closest neighbors and decide the label for the new data point. Weights is uniform, and also x and y. So now we have a new data point. Its coordinates is 1, 6. For example, it's about here. So based on our human judge, and we think, hey, this one seemingly it's much closer to the green cluster. Does the model do this as well? So we will do predict, and then we will use the PN model to make predictions on this. And then we use scatter plotting. So now you can see, hey, this is the data point. And for the color, it's green. So it predicts it's green, belongs to the green cluster. So it's okay. And then the next important machine learning task is clustering. Means like you divide data points into several groups based on their features. In the same group, the data points are more similar to the data points than the data points in different groups. We have other machine learning algorithms, for example, k-means clustering. You can see it's actually very similar. First, we get to the data point, get to the data, or here we generate the data points. And then we create a model instance, for example, k-means, and then we use the fit function to fit the data into the model and then get it trained. And then we make some predictions. So this is a pretty standard workflow for machine learning. So now we choose, hey, for example, we have these data points, and then we want to cluster them, dividing them into 4 clusters. So this is the feed function, the X. Clustering is unsupervised learning, so it doesn't have the label. But here that's why we just have X. And also we can output the cluster centers or so-called centroids to see their the center of the clusters. So original classification is like this. X, so either X, X, Y, because we actually, when we generate the data points, we have put it, so we can check which cluster. And then when we make a prediction, we can see how well the cluster centers are. So you see, this is the green, the center for the green cluster. This is the center for the yellow cluster. This is the center for the purple, and this is for the blue center. So seems okay. We have learned about linear regression. Besides the linear fitting, we also do a polynomial fitting, and then we do the machine learning classification. We use SVM and kitten as an example for classification. And for clustering, we have the k-means clustering model used in this example. Yeah, you can practice these after this class as well. Go to my file browser. The last one is deep learning with PyTorch. I know some of you guys use PyTorch, some of you guys use TensorFlow, but it's very similar. So I will use the PyTorch as an example. So you can see we imported some modules like Torch, Torch NN, Torch Optimizer, Torch Vision for the dataset, transforms. So we import all these. And also we have a course called Introduction to Deep Learning with PyTorch. So if you want to learn more about PyTorch, you can take that course. And also for TensorFlow, also have a similar course as well, Introduction to Deep Learning with the TensorFlow. So if you want to learn more about TensorFlow, you can take that course, register that course as well. So now we will need to check, because we want to run the model on a GPU, we want to check if the GPU is available, and we will be using the Torch CUDA is available. And if it's available, we will be printing the CUDA 0, the index is 0. If you don't have a CUDA GPU, we will be using CPU. So now we have the GPU. So this is very standard, simple neural network. We have some convolutional neural network, convolutional layer, mass pooling layer, convolutional layer, some fully connected layers. And then, so this is 10 classes. So we are doing MNIST classification. So MNIST is a digit classification, handwritten digit classification. It has numbers from 0 to 9, handwritten digits from 0 to 9. So so that's why the last one has, the output layer has 10 outputs for the 10 numbers. And then we run this. And now we will create a model instance called net, and also we will move it to the GPU device. So it's CUDA 0, and so it will be running on the GPU. However, if you comment this line and uncomment this line, it will be running on the CPU. And for next, we will need to define the loss function, and also check the arrows and optimizers to update the model weights or parameters. So we use the SGD and also cross entropy loss. So this is how we define them. And also this is for the data set. You can see I have the data folder here now. If you don't have, if you haven't run these, if you don't have the data directory, these will download it into your current directory. So, and it will apply the transform as well. Transforms, for example, to tensor and normalize it. And this will create the training loader. So using the torch-utils data loader, and set the batch size to be 64, and it will be shuffled. After that, we will timing the training process. That's why I put the time.time here at the end. Also, there's a time.time. So we subtract the ending time from the starting time. We will get the elapsed training time in seconds. So let me run the, before I start running, I will open a terminal. You can see I'm on a GPU node, which is AC064. If I use watch NVIDIA -SMI, you can see, I can see the GPU, which is A30. We have some lucky attendees who got H100 GPUs. But now you can see actually it's just occupied, but the GPU utilization is 0. It doesn't do anything yet. So let me start the training process. So means I will run this. So now you can see it's training and printing the loss. If I go back to my terminal, you can see the GPU utilization is bigger than 0 now. It's 18. This is a very small model, and the data set is small as well. So the memory usage of the GPU and the utilization of the GPU is small. If you run large language models, or even not large language models, or ResNet 50 model on these GPUs, the memory usage and the GPU is high, and also the GPU utilization can reach close to 100%. So, and also this depending on your batch size. So if you use a large batch size, the memory usage will be larger. We just choose a batch size, I guess it's 64, because the MNIST image is small image, small grayscale image, 28 by 28, I think. So even we use 64, the memory usage is small. So now it's 0 now. So I guess it finishes training on this one. Yes, you can see we run 10 epochs of this training. So the loss was originally 2 point something, but after 10 epochs, the loss is 0.05. And also the training time is about 53 seconds. I guess if you are on H100, the training time may be less than 53. But because this is a small model and small data set, so I guess the computing capability is not fully utilized on the H100. So I guess it's it won't be a lot. less than 853. So on CPUs, it could be take much longer. It could be several times of these, I guess. Maybe several hundreds seconds. If some of you guys on CPU node, you guys can run the training and to see. I don't want you guys to wait for a long time. And then after that, we can save the trained model weights. For example, now we have the save the model weights. And for example, when I can save it on my disk, and then I can load it back when I want to use it. I don't have to train the model again. So you can use torch.load to load it back. And then you can do the evaluation of the model as well. Here, we are doing some test data set and also create a testing data loader. So we will do the data in testing data loader. So now we don't have to do the graded computation. So torch no gradient. And then we can run this and to see the accuracy on the testing data set. It's about 98.5, so it's not bad. Do I have anything? I will go back to, yes.
Yeah,
Estimate.
question. Yes. So how, when we are getting the data to test, right? How can we be sure that we're not using data that we used to train the model?
Great question. For here, you can see we have an argument called train. We are using false. I guess it's I think even for MNIST, it has already separated the whole data set into a training set and a testing set. If I remember correctly, the training set is about 60,000 images and the testing data set is about 10,000. So for here, we are using the testing data set. So for your own data set, you will have to make sure that you are not using the data points in the training for testing purposes.
Thank you. So how will you know that one? So you can go to the directory of the data. Is it just based on the names of the files that are in the data directory?
Okay, let me go. Yeah, these are the train. I didn't go directly into here. There are train images, some zipped file. Guess this is the train and this is the test. Oh, this is 10,000, right? These are for the testing. These are for the training. Yes, good question. For training and testing, we should use a different data for training and testing purposes. Otherwise, if you let the trained model to work on the images that it used to train for training, and that's not good. So we should separate the data set. Okay, thank you for your question. And also I want to mention again that we welcome collaboration. If you think your research is good for H100 or Intel data GPUs, and also we have intelligence processing units, you want to incorporate them to speed up your research workflow, you can contact us and we will try to help you to port your workflow to the accelerators so we can check the performance to see if you gain the speed up. Okay, these are all the ACES accelerators we have. I'm not sure if you're interested in any of these. For example, for AI machine learning, IPUs, H100, Intel PVC GPUs are very popular. And if you want to collaborate, we welcome. So Esteban, do you still have a question?
Yes, I have another question, kind of on the practical thing. You mentioned that the NIST, I think, database, the images are really small, right?
Yes.
for the individual images. So from practical sense, if you have an image that is significantly larger, or actually a kind of a meta image that you have three-dimensional cubes kind of thing of information,
Yeah.
how, practically speaking, how big should be each individual entry that you can use for the training, right? You may have thousands and thousands of them, but how big each individual entry can practically be to train these models in a realistic amount of time?
Good question. So you are thinking about like for how big each batch of the images should you send to the GPU, right? Sometimes if you send a very large batch, it can be out of memory for the GPU. Because for our A30 has a smaller memory, GPU memory, but for H100, it has large memory of 80 gigabyte. So it can, I think for my testing for on ImageNet, it's a much bigger than the MNIST. It's about like 200 or 300 times three. I think it's a 256 by 256. And someone reminds me of the size of the ImageNet. And three color channels. So for that one, I think I on NVIDIA H100 I go up to 512 batch size. And if I go more to like 1024, it will give me, hey, you are out of memory. We cannot accommodate this large batch size. So you will have to do trial and error to find the largest batch size you can send it to the GPU. And also for other data set, for example, the language model data set, for example, maybe you use the wiki test or some others, you will have to test, hey, how big batch size I should send it to. Sometimes we worked on the BERT large model using the wiki test. I think when we go to the 64 batch size, it will after beyond that, it will give you out of a memory error. So that means, hey, the GPU cannot accommodate that batch size of data.
Yeah. So it depends on the exact system, right? You have to tailor the
Yes.
data you want to train.
Yes, the GPU memory is also very important. I think the H100 has 80 gigabyte. The IPU has a smaller GPUs, but it's good for fine-grained parallel. It's not like GPU, but it's also the processors. I want to mention a little bit about the IPU. It's MIMD, meaning like multiple instruction, multiple data. So it can do like parallel different instructions on the smaller data set. So it could be for some group convolution or normalization. The fine-grained parallelism is very good. So this is for the IPU, but for H100 it should be larger scale matrix computation. Okay, before we leave, I want to mention something else. Okay, my connection to the JupyterLab server has disconnected. If you go to your folder, now I cannot click it. I also have a Slurm JavaScript and a Python script. Besides using JupyterLab, you can also just use submit Python a Slurm job to the server, and I know sometimes people just not necessarily using Jupyter Notebook. You want to run with your scripts, Python scripts. You can submit a job script to the cluster as well. So that's one thing I want to mention. But the server connection is disconnected. So I think if you still have time, you can click on here, go to the AI TechLab directory, and you have the main.py, and also you have the job summit script. You can do it differently. Okay, I think that's all for today. Thank you guys again. And I think it's lunchtime for the Central Time now. Hope you guys enjoy your lunch. If you have any questions, you can still contact us by sending emails to the help desk email. Thank you, guys.